So ever since I was little, Christmas has always been one of my favorite holidays. And whenever December rolls around, my mom and I both have this special tradition where we always bake gingerbread cookies. And baking is a long process with lots of different steps. But the first thing that you have to do is look at the recipe. And when we look at the recipe, we're able to see exactly what ingredients are needed and how many of them are necessary for whatever we're trying to bake. So when we bake our gingerbread cookies, first we have to mix together flour and water and all of that to create the dough. And when we have that dough, we are then able to break it down into smaller pieces to produce a lot of cookies for our friends and family. Once we have those cookies prepared and we're able to put them in the oven and heat them up so that we can bake them and get something really tasty. So once we had our cookies, we would all gather around the kitchen countertop and we try them and taste them. And I remember thinking about how each bite tasted with every second that I was eating them. But one thing I didn't think about was how with every second, 37 trillion different chemical reactions were happening with every chew and swallow. And hundreds of thousands of different metabolites were being involved in those chemical reactions. But what are metabolites and how are all these chemical reactions happening in our bodies? Metabolomics is the study of all of the chemical reactions that happen within a living organism. And the human metabolome is the collection of the human metabolites. And these metabolites are chemical byproducts that are produced and used up in different chemical reactions within the body. In metabolomics, we can study everything from the way chocolate and coffee are used by our bodies and they increase alertness, to even the way adverse childhood experiences affect neurodevelopment in children. So metabolomics is really just complex baking and cooking. And the first thing we have to do in metabolomics is look at what metabolites are in our bodies and how many of them there are. So kind of like reading a recipe. And for this, we use mass spectrometry, where we send energy out to a cell or a tissue. And based on the energy we get back, we can look at a graph like this and see what metabolites are in our bodies and what concentrations there are. Then we have the process of breaking things down and building them back up, because all these metabolites are involved in different chemical reactions. And there are two main chemical reactions, catabolism and anabolism. In catabolism, it's kind of like with our dough when we broke it down into smaller pieces to bake more cookies. That's just breaking up large compounds into smaller ones to produce energy. Anabolism is the opposite. So we're taking smaller compounds and building them back up to produce energy as well. And with all of these chemical reactions, there's multiple processes and steps, sort of like all the steps required in baking. But it's not as simple as heating something up or putting it in the oven. With metabolomics, millions of chemical reactions can occur from a single chemical reaction or metabolite. And it's sort of like a domino effect, where one reaction can cause millions of others to occur. And that's why adverse childhood experiences can be so detrimental to adult development, and they actually seriously increase the risk for adult onset diseases, because one chemical reaction can cause millions of others to occur, and when that reaction is prolonged, it can have a serious effect. Adverse childhood experiences are 10 different events that can occur before the age of 18, broken down into 3 separate categories: abuse, neglect, and household trauma. In those 3 categories, it's been shown that at least 60% of the American population has one ACE, and those with 6 or more ACEs are actually likely to die 20 years earlier than those without any. It's been shown that anyone with ACEs is at risk for cognitive impairment, the adoption of health risk behaviors, disease and disability, and even early death. So with these adverse childhood experiences, the reason why they're so detrimental is that they cause the fight or flight response to be enacted. When something traumatic happens and a threat is introduced to the body, the brain activates neural mechanisms that cause stress hormones to be released. And those stress hormones are catecholamines. Catecholamines include adrenaline, also known as epinephrine, noradrenaline, norepinephrine, and dopamine. And when those stress hormones are released over time, they actually cause a tolerance to be built up in the body, and they can wreak havoc on your DNA and actually change the way it's transcribed. So these stress hormones are all regulated by the Hpa axis. And there's 3 parts of the Hpa axis: the hypothalamus, the pituitary gland, and the adrenal gland located in the kidney. The hypothalamus releases corticotropin releasing factor, which in turn stimulates ACTH to be released from the pituitary gland, ultimately causing catecholamines to be released from the adrenal gland. But how are these catecholamines released, and how are these stress hormones really affecting our bodies? I've been looking at the catecholamine biosynthesis pathway using Pathways, an online biological pathway diagrammer. And in this diagram, I've seen how the process starts in the adrenal medulla when the ACTH activates this pathway. And the pathway has 4 main enzymes that are used in these neurons that actually produce these stress hormones. And it starts when oxygen, L-tyrosine, and cyproterine all are reacting together via the tyrosine hydroxylase enzyme, producing water, BH2, and L-DOPA. L-DOPA is really important because it's the immediate precursor to the response of L-dopamine. And dopamine is our first catecholamine in this process. So L-DOPA actually reacts via the AADC enzyme, and when it reacts with that enzyme, it produces carbon dioxide and dopamine, our first stress hormone. When that dopamine reacts with oxygen and ascorbic acid, it then is reacting via the dopamine beta hydroxylase enzyme, in turn causing water, dehydroascorbic acid to be produced, and norepinephrine, our second catecholamine. And norepinephrine is noradrenaline. So this in turn can be used to produce adrenaline. Norepinephrine reacts with S-adenosylmethionine, and it's in the PNMT enzyme. So when all of these react via the PNMT enzyme, it produces S-adenosylhomocysteine, and eventually epinephrine, which is adrenaline. So now that we have all 3 catecholamines produced, they enter our bloodstream, and when they enter our bloodstream, our blood vessels constrict, our muscles tense up, and our heartbeat and respiratory rate are upregulated. Once this happens, they finally reach our brain, where the sympathetic nervous system can cause more of these hormones to be released and activated, and it can even cause the parasympathetic nervous system to be unable to stop this release. A lot of people know about cortisol, but cortisol isn't actually a catecholamine. It's released on the heels of epinephrine, and it has a big role in this system, but it's not actually a stress hormone that's involved in this biosynthesis. Cortisol releases negative feedback that causes this parasympathetic nervous system to come into action and stop all of these chemicals from really changing the way our neuronal pathways work. So with this knowledge of the catecholamine biosynthesis, we're actually able to see how all these traumatic events that happen during childhood upregulate the hormone system, and then people are unable to stop the chronic inflammation in their bodies that leads to diabetes, obesity, depression, and many other adult onset diseases. That's why I'm looking at the catecholamine biosynthesis pathway to find how we can create the first ever pathway of the response between ACEs, the Hpa Axis, and adult onset diseases, so that doctors are better able to isolate the real root of the problem of these adult onset diseases in personalized medicine. Now, fortunately, doctors have many ways that they're already looking to treat ACEs. And it first comes with just deregulating the stress response in people's systems. And that comes with increasing your exercise, better nutrition, and more regular sleep patterns. This will decrease the amount of stress hormones produced in your body on a regular basis, decreasing that tolerance and making that sensitivity come back up again so that less catecholamines are produced every time the fight or flight response is caused, and your body can actually function again. So that doesn't mean that we're going to stop eating cookies and we're just going to start eating healthy again. Well, it's actually shown that increased quality of life and in the taking up of a hobby can also decrease your stress response and cause all these stress hormones to be regulated better even more. So this holiday season, I encourage you to take a break, really bake some cookies, enjoy a hobby, and really think about your life, because you might actually be adding years back. Thank you.